8.1 is entitled Radians, Displacement, Velocity, and Acceleration of the Rotational Kind. So we're going to be talking about radians today. Some of you may have heard this before and you might be saying, oh my gosh, I hate radians. And displacement, velocity, and acceleration, there's something that we're going to talk about rotationally. So things going in a circle. So first of all, radians. What radians are, they're a way to measure an angle. Now, I don't know if you've thought about this, but like a right angle. What crackpot said that this is 90 degrees? Do you ever think about that? Like, why is it 90? Like, what makes this 90? Why shouldn't it be 100? And actually, there's another unit of measure, 100 radians. Another thing, in the radian world, this is equal to pi over 2. So in the radian world, there's all sorts of ways. We could call this a 1 hair too. It's also 1 hair. Look at there. Bam! These are all ways to measure angles. A hair, a radian, a gradient, a degree. And they're all measuring the same thing. So we're going to focus primarily on radians. And 1 revolution equals 2 pi radians. On the side, it also equals 4 hairs. But 1 revolution equals 2 pi radians. So we're going to be dealing with radians quite a bit. And so that's thing number 1. 1 revolution equals 2 pi radians. Kaboom. Next, we're going to talk about displacement, velocity, and acceleration. And let me write that. Displacement, velocity, and acceleration. Now, everything we've learned up to this point, we have been dealing with linear displacement, velocity, acceleration. I want to talk for a second about angular. Now, let's compare the two. In displacement is just how far something goes. Velocity is how fast. And acceleration is if you're slowing or speeding. That's the definition. Now, in the angular world, it's the same thing. To define these things, all you have to do is add the word rotates. So angular, how fast it rotates. I'm sorry, not how fast. This first one's going to be how far. How far it rotates. The next one's how fast it rotates. And then acceleration is the rotation speeding or slowing. So they're very similar in that fact, except this is going in a straight line, this is moving in a circle. Now, the units. The units of displacement are meters. The units of velocity are meters per second, and the units of acceleration are meters per second squared. Check out the units for angular. Radians. Radians per second. See the connection? Radians per second squared. Sometimes when we see this stuff in equations, so the variable. What variable do you see when you see displacement in an equation? We use the variable d, like velocity equals distance over time. Velocity obviously v. In acceleration, we use the letter a. Over in angular, we use the Greek letter theta. For angular velocity, how fast something is rotating, we use the Greek letter omega. And then for angular acceleration, we use the Greek letter alpha. And it's funny because remember how I wrote velocity equals distance over time? Watch this. Velocity equals distance over time. And over here, acceleration is your change in velocity over change in time. Acceleration equals change in velocity over change in time. Boom. So, linear, angular, they're very similar. This is just a straight line. These are things all going in a circle. Now we can relate the two of these. If I want to go from linear to angular. For instance, what if I was walking a cross-country course and I had my little wheel that rotates and counts? If I walk a linear distance of 5,000 meters, how many times, what's the angular displacement? How many rotations does my wheel go? Going from linear to angular. If I'm running on a cross-country course, how fast does this rotate? If I'm accelerating, so if I want to go from linear to angular, it works like this. This is kind of cool. Watch how this works. Distance equals radius times angular distance. Velocity equals radius times angular velocity. Acceleration equals radius times angular acceleration. Like that. And it's really cool how these all work. As long as you're all in these all have to be radians. You can't do this in degrees. Has to be in radians. For instance, let me give you an example problem. Mr. Hare walks 5,000 meters with a 0.25 meter radius wheel. How many times does it turn? So that's angular displacement. So I'm going to utilize this equation right here. So distance, 5,000 meters. The radius is 0.25 meters, and so I just take 5,000 divided by, or multiply by 2, and that's 20,000. Multiply by 4. Radians. So that's 20,000 radians. So what you may have to do, I wonder how many degrees that is. 20,000 radians. Remember that there's 2 pi radians and 360 degrees. So you take 20,000 times 360 divided by 2 pi. And you get, oh boy, big number, 1,145,000. That's crazy. I wonder how many rotations that is. So I can take 20,000 radians and change radians into revolutions. Because remember, 1 revolution is 2 pi radians. So I can also do this. So just take 20,000 divided by 2 pi. So it's 3,200 revolutions. Right? Now I could do the same thing. I could say Mr. Hare runs at 10 meters per second. What's the angular velocity of his wheel? So here's like kind of a different problem, but I'm going to use this equation. I'm running at 10 meters per second. The radius is still the same. What's my angular speed? So my angular velocity is going to be 40 radians per second, right? Radians per second. So I could change that into RPM if I wanted to. So I take 40 radians per second, and let's say I want to make it into RPM. So I'll put radians down here in rotation. So one rotation is 2 pi radians, and there's 60 seconds in 1 minute. So radians cancel, seconds cancel, and I'm left with rotations per minute. So 40 times 60 divided by 2 pi, and I get 381 RPM. So these are ways to take angular measures and convert them into linear measures, or vice versa, linear into angular. So here's a summary. We're going to be dealing a lot with radians in this chapter. In fact, everything's going to be radians. Don't think of this angle as 90 degrees. Think of it as pi over 2. 1 revolution, so if you go around the circle once, that is 2 pi radians. Around the circle once, 2 pi radians. And then displacement, velocity, acceleration. How do we talk about things that are spinning? Like if you want to know how far it's spinned, that's displacement. We measure it in radians. If you want to know how fast something is spinning, we measure it in radians per second. You can also measure it in RPM, which I showed you. It's really simple to change radians or rotations, seconds into minutes. It's just a dimensional analysis. And then, is something speeding up or slowing down? Radians per second squared. And all the same equations apply. Velocity equals distance over time. Velocity equals distance over time. Acceleration, change in velocity over time. Acceleration, change in velocity over time. These are new right here. These are brand new equations that we're going to add to the equations on the board. Linear distance is equal to the radius times angular distance. Velocity equals radius times angular velocity. Acceleration is equal to radius times angular acceleration. And I did an example problem down here of me walking a certain distance. What is that angular distance using that equation? Me running at a certain speed. What is that in angular speed if I had a wheel?